Hello, hi everyone. Welcome to Student the Brand. This is your Shiva sir. Today topic is electric current. CBSE Grade 10 Physics. Electric current. CBSE Grade 10 Physics. Right? Yes. Chalo. We'll start the topics. Very important topic. Okay. So we need to practice a lot. Problems also we have to do it. Okay. Problems also will do it. Few problems. Maximum today I'll explain theory. So if it is possible, related to that, how they will ask problems and where we need to concentrate, how to uh, how to attempt the questions and what type of questions they will ask. So those points also we'll discuss. So be ready for it. Light electric current, right? Electric current, CBSE grade 10 physics. What is the electric current? Normally, we can say the total net charge crossing through a unit cross section area per second. So if you say general, if you take generally, total net charge passing through unit cross section area per second. Hi Shivani, how are you? So after so many days, after long time. Okay, done. Great. Now, electric current. Electric current. Electric current. The rate of flow of charge. Electric current. Electric current is nothing but the rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. Okay. So we need to write this small letter. Okay. Here you can observe I am writing small letter, right? Initially unit for units. I am writing units starting with a small letter. On honoring the scientist we are writing. But symbol we can take capital A. And charge is coulomb. SI unit of charge is coulomb and SI unit of time is second. Right? Now, charge we can say C and time anyway, seconds we are taking, right? Okay, 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Sir, can you explain the SI unit of electric current? Or can you define SI unit of electric current? Define SI unit of electric current. Sometimes in the exam they will ask this question. Sometimes in the exam they will ask this question. What is that question? Define SI unit of electric current. Define SI unit of electric current. SI unit of electric current is defined as 1 ampere of current is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Yeah. Okay, right now I am explaining electric current. So definitely, if it is possible, I will explain radioactivity. So arts is fun. Great. Okay, done. I hope it is very clear. 1 ampere equal to 1 coulomb per 1 second. So this is about electric current. So I have one question. Is If only one electron or only positive charge, negative charge, if it is flows in the conductor, can we say current is flowing? Can we say current is flowing? Only one electron is flowing. Only positive charge is flowing in the conductor. Only negative charge is flowing in the conductor. Moving in the conductor. Okay. So, will you say current is flowing in the conductor? Yes? Yes or no? We can't say like that. We can't say current is flowing in the conductor. So, number of charges are moving. Number of charges. Only one or two if it is flows, we can't say. But the number of charges are moving inside of the conductor, then we can say current is flowing in the conductor. Number of charges. Number of charges here. So, number of charges. Number of charges. So, what do you mean number of charges? Means charges here, positive charges or negative charges are there. Positive charges are there. At the same time, negative charges also there. So charges are moving inside of the conductor. Integral multiple. So charges are moving in the format of integral multiple. Number of charges n. So Q equal to Q, here I said no, Q equal to plus or minus Ne. As I said, positive charges are there as well as negative charges are there. Okay, done. So on one electron, electromotive force. Okay, so yes, I'll explain. Nanda Kishore, I'll explain. Not now because we are doing this one. I will explain later. So once if it is done, then I'll explain, because this topic is different, that topic is different. So those who have any doubts in the particular topic, running topic, whatever I'm explaining on that, if you have any doubt, you can ask. So definitely with the topic, your doubt also I will explain. So your doubt also will be clarified along with the concept explanation. Okay, done. So if you're asking remaining topic, maybe it may take time because I need to complete this concept. Then I'll go to the your doubt. Right? Okay, done. Come to the point. On one electron, 1.6 into 10 power minus 19 coulomb. So there is a question on this. So very important question, expected question. They will ask on this one. On one electron, how much charge is present? First question. On one electron, how much charge is present? First question. Second question is, so will the charge is less than this value? Charge is less than this value exist or not? Okay. So less than this value does not exist on one electron. So charge is 1.6 into 10 power minus 19 coulomb. Okay, in 1 coulomb, how many electrons are present? So 1.6 into 10 power minus 19. Then 1 coulomb equal to 1 by 1.6 into 10 power 19. Then 1 by 1.6 into 10 by 10. They will get 10 power 19. 10 power 19. Okay, 10 power 19. So I'll get this one. Now, so if you do it, 10 by 16 into 10 power 19, then if you do it 0.625 into 0.625 into 10 power 19, then 6.25 into coulomb, 6.25 into 10 power 18 electrons are present. So in one coulomb, 6.25 into 10 power 18 electrons are present. I hope it is very clear. So check once here. So electric current, the rate of flow of charge. So on one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. Hi, I'm good. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. I hope it is very clear to you all, right? Yes. Now, chalo, next topic. We'll discuss electrical appliances. Maximum on this concept. So we can expect 1 or 2 questions, 1 mark questions, even MCQs also we can expect from this concept. So how they will ask in MCQs? On 1 electron, how much charge is present? In 1 coulomb, how many electrons are present? Q equal to Ne and current. So SI unit of current and SI unit of current. SI unit of current they will ask, and definition of current, and next one SI unit of charge. SI unit of charge. There are many ways where they can ask the questions. Yeah, I'm doing good. Thank you for asking, Notion. Thank you so much. Okay, done. Now, I hope it is very clear. Just now I explained about electric current. Now we will discuss about electrical appliances. Okay, so be ready for it. First one is cell. This is the cell. Positive terminal, negative terminal. Coming to the battery. So positive terminal, negative terminal. Coming to third one, switch. This is switch. Open switch. Coming to the fourth one, closed switch. Closed switch is there. Okay, open switch and closed switch. Closed switch. Open switch and closed switch. And coming to the fifth one, resistor. Resistor is very important. Resistor are so sorry. Restart this. Okay, fine. This is restart. Restart, and sixth one is resistor. Resistor. Resistor here. So cell, battery, switch, open switch, closed switch, rheostat, resistor. Coming to seventh one is ammeter. Ammeter. This is ammeter. And eighth one is voltmeter. Ninth one is wire joining, wire crossing. And 11th one is bulb. Okay. So these are the electrical appliances. Right now it's going CBSE grade 10 physics. So this is for 10th class. Even it will be helpful for grade 12 also. Grade 12 actually it is. So these topics are repeating in grade 12. Basics only. Hi everyone, welcome to the class. Okay, done. Electrical appliances completed. Now I will explain about electric circuit. Electric circuit. Electric circuit. Electric circuit. 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 Electric circuit. Electric circuit. So what do you mean by electric circuit? Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. So here I am taking this a battery, a switch, battery, switch, and this the bulb. This the bulb. Okay, current is start flowing. Current is start flowing. So this the bulb. So bulb is glowing because switch is on. Okay. So current is start moving, right? Current is start flowing. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Okay. So first one here, conventional current. There are two types. One is conventional current. Conventional current. Conventional. Conventional current. And second one is electric current. Electric current. Electric current. Electric current. So what do you mean by conventional current and electric current? Conventional current is nothing but the flow of positive charges. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Flow of conventional current. So flow of positive charges. 1 minute. Just 1 minute. Yes. Chalo, let's start. Conventional current and electric current. So what is a conventional current? Conventional current is nothing but the flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. Okay, so here I am saying, so here you can observe. So positive charge here, this side negative charges are moving, negative charge. So the flow of positive charges will be considered as a conventional current. The flow of electrons is known as electric current. The flow of positive charges is known as conventional current. So the flow of electrons is known as electric current. So conventional current will move from high potential to low potential, whereas electric current will move from low potential to high potential. So conventional current will move from, that is nothing but positive charges will move from high potential to low potential, whereas electric current, so negative charges will move from negative terminal to positive terminal. I hope it is very clear, right? So these are the 2 points. These are 2 points, very very important. The direction of flow, the direction of conventional current is the direction of flow of positive charges. The direction of current, the direction of conventional current is taken as the direction of flow of positive charges. So the direction of electric current is the direction of the direction of flow of electrons. The direction of flow of electrons is called electric current. I hope it is very clear, right? So these are the two terms, conventional current and electric current. Conventional current and electric current. So next I will discuss about electrical potential and potential difference. Electrical potential and potential difference. electrical potential and potential difference. What is electrical potential and potential difference? So now you can observe here. Now you can observe. Potential difference and electrical potential. Potential difference. Potential difference. Potential difference is nothing but the work done to bring unit positive charge. The work done to bring unit positive charge. So here I am taking. So this is a positive charge Q, and this one point and this one point we are doing some work. So work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called, what is that? Potential difference. So SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. 1 volt is defined as 1 coulomb of charge flowing through unit cross section. In 1 volt is defined as 1 joule of work is done to bring unit positive charge. So from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So especially if you are taking 1 volt, 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. That is called potential difference. Coming to the electrical potential, electrical potential electrical electrical potential. Electrical potential is nothing but, so work done to bring unit positive charge from infinity to the required field. Suppose if you are taking this is the field, so this is a positive charge, infinity we are doing some work. Work done to bring unit positive charge from infinity to the required field. From infinity to the required field. Okay. So work done to bring unit positive charge from infinity to the required field is called electrical potential. So V equal to W by Q, same W by Q. Okay. So this is about potential difference and electrical potential. Electrical potential. Yes, right. Next, so we'll discuss one more, that is Ohm's law, Ohm's law, Ohm's law. So I'll explain about Ohm's law. Explain about Ohm's law. Yes, someone is saying remove the helmet. Okay, yes, I removed. Fine. Then without helmet, we can discuss. Can you explain class 10? Yes. Prism diagram. Okay, sure. Now topic is going on electric current, right? Now I will explain about electric current. Later I will explain about the prism. Okay, Ohm's law. Ohm's law. So what is Ohm's law? Ohm's law is nothing but current is flowing through the conductor. Okay, resistor if you take. the potential difference developed across the ends of the given metallic conductor, or simply we can say the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. V equal to IR. V equal to IR. Okay. So now you can observe V equal to IR. So this is the resistor. I am taking the potential difference here. Switch I am taking. Switch I am considering here. Positive terminal, negative terminal. And here ammeter and cells. How many? 1, 2, 3, 4. 4 cells we have to take. So absolutely I am a physics teacher, no doubt at all. So no need to get confused. 1, 2, 3, 4. Okay, so here. So positive terminal, negative terminal, current is flowing. So current is flowing. Oh my god. So current is flowing. So current is flowing. Current is flowing. Current is start moving from positive terminal to negative terminal, right? Okay. So positive terminal to negative terminal current is flowing. V is directly proportional to I. V is directly proportional to I. V equal to IR. V is directly proportional to V is directly proportional to current is passing from positive terminal to negative terminal. Okay. Resistor, voltmeter, ammeter, switch, cells, number of cells. Okay. I hope it is very clear, right? Now, the potential difference across the ends of the given metallic conductor. V is directly proportional to I. V equal to IR. V equal to IR. V equal to IR. Now, materials required. What are the materials required? Now we will discuss. Materials required. Materials required. So 4 cells. We need 4 cells. What are those 4 cells? 1.5 volts each. Each cell is 1.5 volts. And coming to the second one. Second one, we need resistor. Resistor is here nichrome wire. Nichrome wire is an ally of nichrome wire. Babu, what is nichrome wire? Nichrome wire. Nichrome wire is an ally of nickel, chromium, manganese. Actually, ammeter is a device which is used to measure the electric current. Okay. So voltmeter is a device which is used to measure the potential difference. Potential difference means difference in electrical pressure. Difference in electrical pressure. So in one place, so high pressure will be there, another place low pressure will be there. Then some difference will be there, then it is start. Okay, na? So we can able to identify how much difference it is. Okay, higher and lower. So like normally temperature difference is there, right? So here 100 degrees centigrade, here 30 degrees centigrade. So what is the difference? 100 minus 30, 70. So who will measure this one? Voltmeter. Like in electrical pressure, that is nothing but potential difference. So potential difference is measured by voltmeter. Ammeter. So how much charge is flowing? How much current is flowing? Okay. So in the current in the conductor. So how much current is flowing? So it won't measure the difference. It won't measure the difference. It measures how much current is flowing. Whatever the difference it is, how much current it is flowing in the conductor, it will measure by the ammeter. So how much difference is there? How much electrical difference is there? Okay. So that will be measured by the voltmeter. If you connect in the place of ammeter, so it won't show any reading because so it is not, there is no difference, right? Same current is flowing. If you take ammeter in the voltmeter condition, okay, slightly gets heated because so ammeter measures same, so same current, right? Because there is a difference. So more current will go, sometimes less current like this. More current when it is going, so it slightly gets heated. That is the difference. That is the reason we are not using ammeter. So ammeter in parallel combination, voltmeter in series combination. I hope it is very clear, right? Arpit Sharma. If it is clear, just let me know. If not, so if you know the answer, your answer, you can also let me know. So finally, we need to learn. That's enough, right? No. I answered your question, right? So just let me know. Is it clear or not? Then we'll go to the another one. Okay, done. Fine. So just go through it. Come to the point. 4 cells, 1.5 volts each. And coming to the nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. And coming to the switch. So switch and coming to the fourth, ammeter and voltmeter, ammeter, and coming to the fifth one is voltmeter, and the sixth one is so I hope it is clear. Ammeter, voltmeter, switch, and done. Connecting wires. Next one we can connecting wires. Connecting wires. Yes, is it clear? Oh, thank you. Thank you, Arpit Sharma. Thank you for confirming. Now you can see 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metal. Switch, ammeter, voltmeter, and connecting wires. Now procedure. What is the procedure? So procedure is, first you have to connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Next connect two cells and note down the reading of ammeter and voltmeter. Next repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. So now repeat the process for 3 and 4. And take the values of or note down the values of ammeter and voltmeter. Once again, I will explain. Listen carefully. Very, very important activity. Ohm's law. So definitely question can be expected from this concept. So there are many ways, not only one way. There are many ways. So we can expect question from this concept. First one is about Ohm's law definition. They will ask, and this is the circuit diagram, and also it is called circuit diagram or schematic diagram, the diagrammatic representation of logical connection of electrical appliances. And materials required: 4 cells, 1.5 volts each. Nichromere is an alloy of nickel, chromium, manganese, and iron metal. Switch, ammeter, voltmeter, connecting wires. So coming to the procedure, first you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4 and note down the values. Note down the values. So yeah, what are the values you observed in the ammeter and voltmeter? So you have to note down those values and mention in the tabular form. Serial number, number of cells, ammeter reading, voltmeter reading, V by I form. So that is nothing but R. V by I is nothing but R only, right? So V equal to IR, V equal to IR, R equal to V by I. So V by I is nothing but R. Okay. So here how many cells we connected? How many cells are connected in circuit? Number of cells, 4 cells. 1, 2, 3, 4. Okay. So 4 cells we connected, right? So note down the readings of 1, 2, 3, 4 also. Done. Fine. I hope it is very clear. Now, ammeter reading, voltmeter reading, and V by I form. Ammeter reading, voltmeter reading, and V by I form. So you can mention the tabular form. If you draw the graph for VI, so if you are taking the graph, sir. So after drawing the graph, if the light rays passing through origin, light rays coming like this. So V on y-axis, I on x-axis, and sir, oh, what do you mean by this graph, sir? So, what is the meaning of this graph? You did just a graph, that's right. What is the meaning of this graph? So, the meaning of the graph is the conductors are circuits or resistors which obey Ohm's law. The conductors are circuits or resistors which obey Ohm's law. Those are called ohmic conductors. Ohmic conductors. V V by I are equal to R. Okay. So the graph is straight line. The graph is straight line passing through origin. Okay. So the graph is linear starting from origin. This shows this is for ohmic conductors. Sir, what is ohmic conductor, sir? What is ohmic conductor? Ohmic conductor is nothing but, as I said just now before, the conductor which obey Ohm's law, the substances which obey Ohm's law, the resistors which obey Ohm's law, the circuits which obey Ohm's law. Understood? Yes, sir. As a student, what we have to do? So we have to come to college or school daily. We have to listen to the teachers' lessons carefully with more discipline, and you have to practice those, and you have to attempt the test, and you have to learn the knowledge. You have to gain the knowledge. Yes or no? You have to gain the knowledge. And one more point. Nowadays, yeah, of course, slope of graph. One more thing we need to add nowadays. So this is not sufficient. One more thing we need to add. We have to develop skills. That is very important. Simply coming, listening, reading, practicing, writing, that is not sufficient. We need to develop skills, thinking ability, analytical ability, yes or no? So, like everything, life skills, these are very, very important, right? We need to develop without any, what we can say, without any substitute. We can't substitute all these things. You have to do it. You have to learn. There is no other option. Yes or no? You need to learn. You have to learn. Then only you will succeed. Right? Yes. Come to the point. Here. Here, the slope of graph. The slope of graph is linear. So that gives the resistance. Okay. So V by I equal to R, right? And one more thing here. This is for ohmic conductors, I said, right? This is for ohmic conductors. The conductors which obey Ohm's law. Ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. The substances, the conductors which does not obey Ohm's law. The conductors, resistors or circuits does not obey Ohm's law. Those are called non-ohmic conductors. Non-ohmic. Non-ohmic. What are those? Non-ohmic. Yeah. Yes or no? Yes. Yes, this is about Ohm's law, very, very important. So please reply. Okay, done. What is your deep focus? There are many questions. So I hope this concept is over. If I enter into the answers, so questions, it will take time. Let me finish the topic, then I will reply. They will answer to your questions. Okay. So shall we go to the next one? Right? Okay. Actually, I will draw one graph. I will ask one question. So, can you actually Ohm's law is applicable for non-ohmic conductors also. So, if you are taking this is V and this is I. So, this is V1 I am taking, this is V2 I am taking here. So, here I am taking this I1, and this one is I2, right? So, V equal to IR formula. So, now V1 by I1. Correct or not? So R equal to V by I. So that is R1. And V2 by I2. That is R2. So I have my question. The question is, will R1 equal to R2? R1 equal to R2? So let me know. R1 equal to R2 or not? Question mark. Okay. So this is the one question. So if you know the answer, let me know. Right? Done. So I am going to the one more topic. Ohm's law completed. Next we will discuss about factors depends on resistance. Factors depends on resistance. R is directly proportional to L. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So I have one more question. Here I am taking the conductor here. This is the conductor. Okay, this is the length. If you increase the length, resistance will increases or not? Yes or no? If you increase, so resistance will increases. Resistance depends on, so normally temperature increases, so molecular speed also increases. Okay, so electron speed also will increases automatically. Bombardment increases, collisions between electrons will increases, then resistance increases, resistivity increases, so everything will increases. By that, resistance increases. If length increases, automatically resistance also increases. Coming to the area of the cross section. So more area of the cross section, there is a chance to enter more electrons. More number of charges will pass. Then there is no resistance. Okay, compared to the first one. So resistance is less. Your resistance is more. Yes or no? There is standard comparison. Okay. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. I hope it is very clear. Now, here R is the resistance, rho is the resistivity. R is the resistance, R is the resistance, rho is the resistivity. So rho is the resistivity. R is the resistance, rho is the resistivity. Okay. Now you can observe rho equal to RA by L. RA by L. Is it clear? Correct? What is SI unit of resistivity? SI unit of resistivity is, here I am taking ohm, area is meter square and length is meter. Meter get cancelled, rho equal to ohm meter. Rho equal to ohm meter. Okay. So R equal to ohm meter square by meter. Meter get cancelled. Resistivity equal to ohm meter. So very important calculation. Very important definition. Okay, so be very clear. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Then you will get SI unit of resistivity is ohm meter. Okay. So these are the and one more thing, resistance depends on temperature, Rho is resistivity. Rho is the resistivity. So resistivity is equal to resistance of the conductor per unit length and unit cross section area. R equal to rho equal to RA by L. So in the definition, it's in the formula itself, definition is there. Rho equal to RA by L. Okay, so rho equal to R by L into A. So resistivity is equal to resistance of the conductor per unit length and unit cross section area. That is called resistivity. So SI unit, definitely one question can be expected. SI unit of resistivity. Make sure that you are learning. Okay, this point. Done. Resistance and resistivity we discussed. So coming to the differences, I will discuss few points. So very important. 3 mark question can be expected even in the competitive exam also. Problems, especially problems are very important related to particular topic. So it depends on simple and important topic which is even used in your engineering. So study this. Oh, thank you. Thank you so much. Manjuna, thank you so much. And okay, then. Resistance R equal to rho into L by A. And first one is resistivity equal to RA by L. And coming to the second one, resistance SI unit is ohm meter. Sorry, here ohm only. Resistivity is ohm meter. Here is ohm. And here is meter. Ohm meter. So this is the SI unit. And coming to the symbol we can take like this, and here symbol ohm meter. And coming to the resistivity, depends on temperature. As I said before, temperature increases, the resistance also increases. Temperature increases, the resistance also increases. Temperature increases, resistance also increases. Here, so temperature increases, resistivity also increases. Coming to the fifth one, material. So it depends on material also. What material you are using for doing experiment, based on that also it depends. So that is material of the conductor. Material of the conductor. So resistance depends on all these 5 factors, and the resistivity also depends. Okay, done. So next topic is resistors are connected in series combination. Resistors are connected in parallel combination. Saru, resistors are connected in series combination. Very good. I can understand. I can agree. So what are you saying? So I hope you are saying good, right? So I am thinking, I'm accepting, I'm listening, I'm understanding, I'm following, I am doing, I am writing, I am practicing, I am learning from you. But still, I have one question, that is, which physical quantity is constant in series combination? And one more question is, which physical quantity is constant in parallel combination? That I'm going to explain. Okay, I will discuss. If you know the answer, you can tell. So I'm repeating the question once again. Which physical quantity is constant in series combination? Point number 1. Point number 2. Which physical quantity is constant in parallel combination? Sir, I have one more doubt, sir. Sir, what is physical quantity? What is physical quantity? Physical quantity. We learnt in 6th class, 7th class, sir. I am studying 10th class, sir. How can I remember all these points? Without studying 6th class, we can't come to 10th class. But at the same time, if you are We need to remember 6th class basics points also, right? So we need to remember all those points. Physical quantity. The quantity which can be measurable. The quantity which can be measurable is called physical quantity. Sir, one more doubt, sir. Physical quantity is measurable. I mean, say the quantity which can be measurable. Can you tell me the examples for physical quantity? Oh, physical quantity examples are there, no? Yes. Can we measure this, right? Of course. Means like 20 grams, 30 grams, 40 grams, 50 grams, 60 grams. It depends. Can we measure this weight? Of course. Yes or no? The quantity which can be measurable. Anything we can take. Okay. So anything we can take. Mass, volume. Is it clear? Done. So shall I continue the next topic? I hope it is very clear. Coming to the resistors are connected in series combination. Resistors are connected in series combination. Series combination. Series combination. Series combination. Series combination. Sir, how can we expect? I'll arise 3 questions. Point number 1. How can we check whether resistors are connected in series or parallel? Second thing, how to identify the resistance, total resistance. And third thing, if n number of resistors are connected in series combination, what is the formula? Now check here. Resistor number 1, resistor number 2, resistor number 3. Only 3 resistors we need to connect, or more than also we can connect? Definitely we can connect many. That is the reason last one I said number of resistors are connected in series combination. What is the formula? I am taking this ammeter, battery, this is a battery, switch. So this is R1, R2, R3, R1, R2, R3, R1, R2, R3, ammeter, ammeter or voltmeter? What I have to connect? Ammeter or voltmeter? Ammeter. No. System is saying wrong. Voltmeter we have to connect. Okay. V1. So next V2. Next V3. Okay. So voltmeter we have to connect. Voltmeter we have to connect. So current is flowing from positive terminal to negative terminal, negative terminal to positive terminal. Current is flowing from negative terminal to positive terminal, positive terminal to negative terminal. Positive or negative? Positive terminal to negative terminal. So I am marking like this. Positive terminal, negative terminal. Switch is closed or open? Shall we leave like that? Shall we leave like that? No, 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 no. There is one point is missing. There is something is missing. What is that? Dot. This dot. Each and every second is very important. Yes or no? Yeah, it is closed now. If you place the dot, the circuit is closed. Now, okay, we know Ohm's law. What is the Ohm's law? Formula. V equal to IR. This is the mathematical formula of Ohm's law. Is there something as natural terminals also positive or negative? Oh my god, oh my god. Okay. So this is the Ohm's law. This is the mathematical formula of Ohm's law. Oh, thank you, Chintu. Parallel plate capacitors. So yeah, definitely I will try, because now it is going on, right? Electric current. Slowly I will start. Slowly I will start. 1800. So thank you so much for listening my class. Definitely I will explain. Okay. Now V equal to IR. Now in this circuit, which one is constant? See, in the previous one. Thank you so much. I have one question. In the previous in the previous concept, like before this one, I asked one question. I asked one question. Question is, which physical quantity is constant in series combination? Which physical quantity is constant in series combination? Physical quantity. In that also I asked one question. Physical quantity. Here, what is the physical quantity? What we can measure? We can measure two. One is potential difference and another one is current. So I connected potential difference R1, R2, R3 across R1, V1, across R2, V2, across R3, V3. So voltmeters I connected across R1, R2, R3. So by this we can understand potential difference is different. But current is flowing throughout the circuit. Current is same. I is same. I is same. Yes or no? I is same. So I is equal to I1 plus I2 plus I3 equal to I. Current is same or not? Yes, current is same. Then V is equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. Shall I take I common? So just now I said no, current is same. Oh my god, this is not plus, right? You are not saying this is not plus, right? Because it is equal symbol. IS, I1, I2, I2. IS equal to I1 equal to I2 equal to I3 equal to I, because entire the circuit current is same. Entire the circuit current is same. Here, one thing I am saying, we are finding the physical quantity only, right? We are finding the final, we are deriving the resistance formula. We are deriving the resistance formula. Yes or no? For that only I am taking potential difference and current. Among this I am telling. Oh my god. Okay, done. So IR is equal to, I am taking common R1 plus R2 plus R3. So I can cancel it. Anyway, current is same only, no? RS equal to R1 plus R2 plus R3. Our final motto is resistors are connected in series combination. Resistors are connected in series combination. We are deriving the formula. Okay, so that is the reason we are taking that one. So I hope it is very clear to you all, right? So potential difference is different because different resistors are connected. Current is same throughout the circuit. Vs equal to V1 plus V2 plus V3. Whatever the potential difference is, okay, from the battery. So here, so that is equal to in series, total series combination, we can say the potential difference in series combination. Vs equal to V1 plus V2 plus V3. Then IRS equal to IR1 plus IR2 plus IR3. So II get cancelled. RS equal to R1 plus 2 plus R3. So shall I go to the next topic, that is resistors are connected in parallel combination? Shall I explain? Right. And I said 3 points. Point number 1. Resistors are connected in series combination. See, entire the circuit current is same. Point number 2. So resistance, total resistance formula are equivalent. Okay, effective resistance or total resistance, equivalent resistance. So anything we can take RS equal to R1 plus R2 plus R3. And the third one is if n number of resistors are connected in series combination. If n number of resistors are connected in series combination, then RS equal to NR. RS equal to NR. If n number of resistors are connected in series combination, RS equal to NR. RS equal to NR. So actually, Dinesh, just now I completed Ohm's law. Okay, just you can go back. Just go back in the live class. Just then you can get it, or you can find, or otherwise after the class also you can watch it. Fine. So this is about resistors are connected in series combination. Now I will explain resistors are connected in parallel combination. 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 So these are the three resistors, 1, 2 and 3. Ammeter, R1, R2, R3. Potential difference. Current is flowing, potential difference. So here R1, I1, I2, I3. So V equal to IR, potential difference V equal to IR, I equal to V by R. So I hope it is very clear. From Ohm's law, so here IP is different, potential difference is same. So throughout all resistors I'm connecting potential difference. Vp equal to V1 equal to V2 equal to V3 equal to V. Now current IP equal to, so I1 plus I2 plus I3. Okay, so current is started flowing from battery. Whatever the current is flowing in the circuit, that is IP equal to I1 plus I2 plus I3. So we need to add all the current. Now I1 plus I2 plus I3. So V by RP. Sir, why you are considering V value? Oh, we can take VP. As I said, V1 equal to V2 equal to V3 equal to V, right? So that's why I'm taking directly R1 and V by R2 plus V by R3. Shall I take V common? Is it okay if I take? Okay. So we don't feel bad. because it is a general process, it is a life. So you have to come out. Then both side I will cancel. You don't worry about it. Don't worry about it. So everyone say bye to V value because I'm canceling. Please, because V value is feeling so bad, so sad because I'm going to cancel on both sides. So I'm canceling. Bye bye. Now 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for resistors are connected in parallel combination. This is the formula for resistors are connected in parallel combination. So 1 by 3. Okay, done. I hope it is very clear. Now check once. Check. Throughout the circuit, current is dividing. Potential difference is same across R1, R2, R3. So across these three resistors, potential difference is same. But current is dividing. So in the junction, so through R1, I1, through R2, I2, through R3, I3, current is different. Potential difference is same. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So I'm taking V common, V get cancelled on both sides. So LHS side and RHS side both sides. So I'm cancelling V. So V get cancelled. Then the final formula is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, if n number of resistors are connected in parallel combination, Saru, you said one point in the previous topic. So just before this one, you said 3 points. So you completed only 2 points. So what about the third point? Third point is if n number of resistors are connected in parallel combination, 1 by Rp equal to R by N. Is it correct? No. 1 by Rp equal to N by R. N by R. P equal to R by N. So generally, students what they will do? After getting values, after doing this one, they will get some value. So something value they will get. Something. Or 2 or 2.5 or 3, something they will get. So they will substitute this value as it is in the problem. They will get the answer. After getting the answer, they will ask, sir, options are wrong. Sir, question formation is wrong. Sir, there is no option in the, there is no answer in the options. Sir, extra mark. Sir, add mark. How it is possible? You didn't take R value. You took 1 by R value. Then how you will get correct answer? So 1 by R value that is. So R value is 1 by R value. R value we need, right? 1 by. So reverse of this one. So that is R value. Understood or not? So you have to take after getting 1 by RP, you should not take directly that one. So I took 2.4 something example. I didn't solve anything. So just I took the formula, something value I took. So from that I'm explaining nothing else. So according to the problem we can solve, and based on that one, after solving this entire thing, you will get 1 by RP. Don't substitute as it is. So we need R value or RP value. So reverse it and substitute. Okay, done. So these are the resistors are connected in series combination and resistors are connected in parallel combination. So I hope it is very clear to you all. Shall I go to the next topic? So are you all ready? Are you listening? Are you following? Are you engaging? Are you watching? Are you practicing with me? Are you focusing? Are you learning? So is it useful to you all? So whatever I'm saying, whatever I'm talking, everything it will be same. Hey, hi, Saham. Welcome to the class World of Physics. Then now this is student demand. Okay, finally. Yes, now we are discussing about, I hope resistors are connected in series, resistors are connected in parallel. So I hope it is completed. Next, we'll discuss about heating effect of electric current. Heating effect of electric current. So V equal to W by Q, W equal to V into Q. So rate of doing work is called power. So that we can say in electrical power. Now VQ by T, we know rate of flow of charge. What is the rate of flow of charge? Anybody? So 1, 2, so I will give 5 seconds. So what is the rate of flow of charge? 1, 2, 3, 4, 5. Wow. Navid, correct. Current. So P equal to VI. P equal to VA. So whatever the energy is given to the conductor, that will be within a particular time. So VI into T. So whatever the given energy to the conductor, that will become in the form of, that will be dissipated, that will be converted. Okay, that will be dissipated in the form of heat. So V equal to, substitute here IR into I into T. So H equal to I square RT, it is also known as Joule's law of heating. Heating effect of electric current. Okay, so H equal to I square RT, it is also known as Joule's law of heating. So heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay, so I hope it is very clear to you all. Then applications of heating effect of electric current. Electrical cooker, electrical oven, water heater. Then any other examples? Hair dryer. There are so many examples are there. So I hope it is very clear to all. So thank you so much for attending and listening and focusing. Heating effect is practically used in chargers of laptop also, that is also heat up. Yes, okay. Okay, thank you so much for listening and joining, attending. So with the patience, attending and listening and learning the knowledge and practicing. So your efforts, one day your efforts will pay definitely, or in the form of success, in the form of honoring, in the form of results. Okay. So thank you so much. Yeah, this is 10th class. So soon I am, as I already started 11th also. 12th it will so I'm going to start because of timings. So it's happening like that, definitely. So thank you so much for joining and attending and listening. So this is our Shiva sir from Student the Brand. If you like the content, if you like the video, if you like my explanation, so if you like the channel, please do like, share and subscribe to Student the Brand. Thank you so much. See you soon in the class.